What's the system of equations? We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. This video is for differential equations students who are going through their first course in differential equations, and they're right smack dab in the middle of solving first order linear differential equations using integrating factors. Now, in this example, if you see something special about this, please don't say anything, because we're going to go through a long-winded process, not too long-winded, but at the end of it, we are going to observe something that would have saved us a lot of time. So the instructions said, solve this ODE, and then state the largest interval over which the general solution is defined. Okay, so you're faced with this. A lot of students will just run right through this. They'll just immediately say like, okay, I just have to solve this, go crazy. First thing they will do, and I think that in general, this is a good tactic, they would divide every term by the coefficient function of dy dt. In fact, you kind of have to do that if you're going to use integrating factors. Integrating factors only work if your coefficient of dy dt is 1. If it's not 1, then you'll need to do something about it. In this case, divide both sides by t squared. So let's go ahead and do that. The odd way I've written this is that I have in the second term on the left-hand side written the t without the negative exponent. In other words, I placed it in the denominator versus the right-hand side where I wrote the expression with t to the negative second power. That's just because I know what I'm going to be doing next, which is integrating the coefficient of y. And because of that, I just like having specifically, if it's t to the negative first, I like to write it as 1 over t. All right, so now that we get to this point, it's probably a good idea just off to the right-hand side to mention the domain issue that you now see in front of you. T cannot be 0. For you to solve this, t cannot be 0. So whatever interval of validity that we get, it will not include 0. All right, now integrating factors. You should already have gone through it. So if this is an instructor watching this, I'm just letting you know, I would never teach it this way. But I'm assuming that your students, or if you are a student, I'm assuming that you have seen the full derivation of solving linear first order differential equations using integrating factors. Because of that, I'm just going to hop right into it. I'm going to let mu equal e to the integral of p of t dt. Now, p of t is actually just the coefficient function attached to y there. So let's go ahead and sub that in and integrate. Now you get to this point right here, and I just want to draw your attention to this. This is going to be e to the 2 natural log absolute value of t plus some constant of integration. And of course, you probably have played this game quite a bit in your differential equations course so far, but this ends up being e to the natural log absolute value of t squared times e to the c sub 1, right? Properties of exponents. And of course, I do realize the absolute value of t squared, the absolute values are unnecessary, but this I want to argue in general what you would do. Okay, so I'm going to leave those absolute values on there for the moment, even though they're not really necessary for this problem. The e to the c sub 1 power, that's just another constant. So I'm going to call that c sub 2. And honestly, the base e exponential and the natural logarithm are inverse functions, and so this would read as follows. Again, I ask your forgiveness in that the absolute values are not needed on this specific example. They were not needed because the coefficient here was a 2, but let's pretend as though it wasn't. Let's pretend as though that coefficient was a 3 or a 5 or a 7 or a 9 or something like that. That is, it could be an odd exponent. Let's just pretend. If that were the case, I tell my students this a lot, that an absolute value can be replaced with a plus minus sign. We just happen to know in truth that the absolute values will only return positive values, but you just don't know what t is. And if the power was odd, you do have the ability to put the plus minus there. But the point of this is the following. Plus or minus a constant is yet another constant. So the absolute values, a plus minus, all that business was really not super necessary when we went through this. Also, you should note when you're using an integrating factor, you're doing so because you're going to multiply everything in this differential equation, all three terms. You're going to multiply those by the integrating factor itself. And if I multiply every term by the integrating factor, which we just found out to be c times t squared, well then every single term will have that c, and I could divide that c out. I mean, really, visualize this with me, would you? If I multiply this by ct squared, and this by ct squared, and this guy by ct squared, I could just divide everything by c. So long story short, you actually don't even need the c that you get, the constant of integration in the end when you're dealing with integrating factors. So I'm going to leave that out of my entire integrating factor conversation. My integrating factor here is mu equals t squared. So I'll go ahead and multiply all terms by that, or I should say just both sides by that. When you do that, the whole point of doing this is so you recognize that that left-hand side is the result of a product rule. This left-hand side right here, by design of using the integrating factor, will become the derivative of the integrating factor times y. Remember, the integrating factor here is t squared, so I could replace that mu with the t squared. It technically is the derivative of t squared times y. That's the entire purpose of multiplying both sides of this equation by the integrating factor. Probably the biggest mistake that's made is that people forget to multiply the right-hand side by the integrating factor, so be very careful about that. And then at this point, we just integrate both sides with respect to t, and then divide everything by t squared. And that's pretty much it. We've solved the differential equation. Now, when I go back, I want to just mention something that you should always be on the lookout for when you're handed a linear differential equation, a first order linear differential equation, that you are intending to use an integrating factor on to force exactness like this. Well, before you even begin, you should probably check to see if that left-hand side is actually just already the result of a product rule. If you look at this is the original differential equation. If you look at this original differential equation, this left-hand side is already the result of a product rule. It's the derivative of t squared times y. So we could have just started with this. And note that right there is exactly where we arrived after a little bit of mathematics. So I just want to make sure that you're very aware of keeping your eyes open for being handed something that's simple. Don't try to overcomplicate it. It's very, very hard to see that in a differential equations course because everything seems to be overly complex. But still, if you can, try to keep your eyes open for any type of pattern like that. All right, that's all I have for this problem. Oh, no, it's not, because I'm supposed to state the largest interval over which the general solution is defined. So let's go ahead and go back here and just mention this is our solution. And remember, solutions to differential equations must be continuous. So this is definitely non-existent at t equals 0. I'll also look at my original differential equation to make sure that there weren't any other domain restrictions. There are no other restrictions. Even when we divided by t squared, we didn't get any restrictions other than t not being 0. So that being said, the largest interval of validity for this, there's actually two possibilities. I'm just going to choose the one where t is positive. And of course, this will depend on your initial condition. So if somebody handed you an initial condition at t equals -5 and y equals 10 or something like that, then obviously this is not your interval of validity. Your interval of validity would go from -infinity to 0, because that's where your value for t for the initial condition sits. Anyhow, now I can stop the video. I hope this helps you out, and I hope you have a wonderful day. Be a great human being.
It's is the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close, don't talk too much that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry.